We are live streaming. Nice. Today we're gonna continue the system design live stream studies with the Isaque Coelho here.
Hey guys.
And we're gonna finish to read the blog spots about Discord. And we're gonna comment and learn a lot about system designs. That's something important to you level up your knowledge about software engineer. Okay, let me check here if the YouTube is working. Yeah. Okay. Nice. I see my voice. Should be okay. So we stopped the reading.
In another one that's trillions, we stop in billions.
Oh.
So yesterday we are talking about how to call store billions of messages, and we stopped where data modeling. We are talking about data modeling, and we stopped in
Dark lunch.
dark launch.
Yes. So if you don't watch the last live, you can check out later. But we're gonna continue here in the dark lunch. If I remember correctly, here they said how they imported all the messages from MongoDB to Cassandra, right?
Yes.
And now the dark launch is, I don't know what it is, we're gonna discover now. So introducing a new system into production is always scary, yeah. So it's a good idea to try to test it without impacting users. We set up our code to double read and write to MongoDB and Cassandra. Immediately after launching, we started getting errors in our bug tracker telling us that author ID was null. Ooh, how can that be null? It's a required field. So how did that we set up our code to double? Oh, I see. I see. They keep the MongoDB as normal, but also write and read in Cassandra. Right? So they have like
two
MongoDB and the application, like the servers cord, and then Cassandra. I don't understand why they put the read also. Maybe just to test. And then here we have double. How put double arrows? What? Here, no, here. No. What? Ah, here. Yeah. So we have read
and write.
And write.
You can put slash. Yeah, that's good.
Yeah, just because I thought why they don't only use write for Cassandra. Why they need read? Why they need read for Cassandra? But it makes sense, right? You're gonna read also from Cassandra and just make sure that the, both data it's equal or if you don't get errors. I think that's the what they did to test. So that's a good pattern to do in production, to do a migration, right? Nice. So eventual consistency. Cassandra, it's a AIP database.
Why is that?
Yeah, that's a good one. So yeah, we have a theorem called CAP. I think it's consistency. I don't remember the A. Acho que é availability and then
it's below.
Yeah,
consistency,
yeah.
availability.
I was trying to remember by myself, but yeah.
Okay.
Yeah. So consistency, availability, and partition tolerance. So the theorem is like a triangle.
Yes, triangle.
How I create a triangle here. Really? Oh,
It's the last button in this interface. Yes.
hmm.
No, they don't have a triangle.
Okay. So it's like that. In the blockchain, in blockchain also we have something like that. So that's the C, that's the A, that's the P. So basically, every time you have a database, you cannot have the three in the same time. Only two. You can only pick two. If you have a database to keep consistency and availability, you're gonna lost partition tolerance. So let's understand what it is. So in database theory, the capturing also named Brewer theorem after the comparison array case something. Nice, California. States states that any distributed data store, it means database distributed, can provide at most two of the following three guarantees. Consistency. Every read receive the most recent write or an error. And consistency as defined in the CAP theory as a quite different from consistency guaranteed in the ACID. ACID, I think it's ACID.
ACD.
Yeah, it's something else about database too. It's something we need to understand better than. Yeah, we're gonna dive deep later. And so basically consistency is you need to read almost all the distributed data or receive an error. Availability, it's every request received by a non-failing node in the system must result in a response. It's a definition, is the definition of availability in capturing as defined by Gilbert and Lynch. By the way, they have good books about that patterns.
Lynch?
Yeah, it's a famous name. I don't remember the first name. David Lynch.
David Lynch.
No, it's not that one.
Cineasta.
No, it's another one. Cannot be that.
Lynch, computer science. Gilbert.
I think Nancy.
Lynch.
Yeah, probably it's Nancy. Yeah.
Yes, MIT. It's a girl, a woman.
Yeah.
Nancy Lynch.
Still alive, looks like.
Yes.
Nice.
He's from MIT.
She is from MIT. And a lot of look at the Drishta. That's a cryptographic.
How to say this name yes, Drishta.
Yeah, it's from the RSA, right? No, DSA.
Yes, I have one book from him, I think. Or he has an algorithm, right?
Yeah.
Let me see. I don't know if this book is. No, but I know about the algorithm. I have this book here. It's. I don't know if you can see, but it's understand algorithms. It's from the little rats, little mouses.
Little mouses.
Yes, ratos, pequenos ratos, little mouses, little rats.
Let me test the chat.
Yo.
Okay, it's working.
Yes.
Okay, yeah, I cannot see, but people are gonna see. Yeah, so
yeah,
that's...
you can search in the entendendo algoritmos.
Entendendo?
Yes. I don't remember the title in English, but in Portuguese is like
probably understanding.
I don't know, but that book.
That one?
Yes.
Let me see. Uh, 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 okay, always I got in the Amazon. I need to check if I expose my SEP, and I do that every time.
Oh,
Yeah. So is that one?
yes, this book is very good.
Mm, cool.
Oh, your recipe is on the.
Yeah,
It's in my recipe.
yeah, I know. I accepted that already. Okay, so let's continue the cap tiering. I don't know why I think I removed the extension for it's very useful for live streams for English.
Which one
That one.
to translate the things?
Yeah. Because I
Mm-hmm.
started learning Japanese, and in
Mm-hmm.
Japanese I have that one for Japanese.
How can you pronounce that? Pronounce that.
Yeah, only works with the Japanese. They don't translate. You
But
see, you
do
understand?
you know how to say this? Feel them in Japanese
No, not yet.
to pronunciate that.
Probably it's a word they call borrow word, and
But
yeah,
mm,
they borrow words, so they're gonna sound likely the same in
mm-hmm.
English.
I know it's like a cognata in Portuguese. We
Yeah,
have that like a banana in Portuguese. In
yeah,
English, it's the same thing.
yeah. So for
Banana.
example, in English, salada, and in Japanese, it's gonna be sarada. Sa-
Furin.
sarada,
Furin.
sarada.
Furin.
Yeah, I don't know why it's not working.
I
Sadly,
think you should start the
page
yes.
probably. Yeah, nice.
theorem,
Furin.
theorem, theorem, theorem,
Theorem,
theorem,
Theorem.
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 theorem, theorem,
So steel, it's
Theo-
like almost
Theorem.
God in another language, and then
Mhm.
rem,
theorem, theorem,
Theorem.
yeah, theorem. So the cap theorem, also named Brewer,
brewers, brewers,
Brewers. It's the last surname, right? Okay. Uh, so availability is every request we received by a known failing node in the system must result in a response. So, like the name say, the, the response or something should be available. Availability, as defined in the CAP, is different from the high availability in software architecture. Okay, so that's just contradict what I said. Nice. So it's different from high availability. That's system that aims to ensure an agreed level of operation and performance. Like you have OpenAI status, you know. So
Very nice.
when you work with the big systems, you must have
I
some
know.
you must have something like that. So that's a high availability, right? And 999% of the time, uptimes, they have some failures, some incidents. Here are a lot of incidents, but it's uptime a lot of the time. Cool stuff. And partition tolerance. So the system continues to operate despite an arbitrary number of the messages being dropped or delayed by the network between the nodes. So when a network partition failure happens, it must be decided either to do one of the follows: cancel the operation and thus decrease the availability but ensure consistency, proceed with the operation and thus it's thus, right?
thus,
No, it's not.
thus,
Thus.
Is that I can
Hmm?
ah yes, tus tus
Th-
fus
thus.
Thus provide
Thus.
availability.
Yeah. And thus provide availability but risk inconsistency. So proceed with the operation and thus provide availability but risk inconsistency. This does not necessarily mean the system is highly available to these users. Thus, if there is a network partition, one has to choose between consistency or availability. So here's the map. So you have CA or AP or CP. So we are reading the article and they said AP here. So
Yes, but
AP.
these three things is the law from databases. It's like a law in databases
What do you,
things or not?
what do you mean?
A law. It's like a
Yeah. It's not a law, but it's kind of they observe that how it works. So theorems, or something they observe. Yeah, we can call law, I think.
yes, because we'll never. That's the theorem saying, right? You will never ever happen in a database with the tree available.
Yeah.
Okay, so that's a law.
It's not a law because normally law you follow, right?
But it's laws of physics, you know? It's like a theorem too.
Yeah, but you can also choose, for example, I can choose consistency and partition tolerance. So that cannot be a law. Law is something like you must follow.
Yes, but
You have a
that's I'm
choice. You have
saying.
choices here.
But never the three at the
It's
same time.
never is a strong word, right?
Yeah, that's I'm asking.
Yeah, that's why I think it's not a law because law is too strong. But
Okay.
gravity, it's something you never change. But here,
Okay.
yeah,
I
maybe
understand.
here in the future we can create something that can provide two, both very good, and that one a little bit. I don't know.
Okay.
Maybe
Now I understand.
maybe with the computer, how to say that, quantum computer.
Yes.
Maybe we can provide something. I don't know. But maybe we can take the
Theorem.
the Wikipedia to. So database theory encapsulates a broad range of topics related to the study and research of the theoretical realm of the database system. So let's see if they call law. No. So let's go to GPT. CAP theorem. It's law. Why not? Nope. It's not a law of nature like physics. Theorem in distributed systems first formalized. It's 25 years. Yeah.
Very
Recent.
recently. Yes.
Distributed systems cannot simultaneously guarantee all three properties. It's more like a mathematical proof constraint than a physical law. Okay.
Cool.
So consistency, every node sees the same data at the same time. We can see examples later. Availability, every request get a response even if not is the latest. And partition tolerance, system keeping working even if networks splits.
Cool.
So they said they have AP, so they can have availability. So the database always gonna respond with some data, even that if that data is not the last updated. And also because they're using like sharding or cluster, the database is gonna be in parts, so we're gonna have a lot of partitions, and the system can have a tolerance to keeping working even if that's divided. Okay. So Cassandra is AP database, which means it trades strong consistency for availability, which is something we want. It's a anti-pattern. It is an anti-pattern to read before write. Yeah, read before write. So we need to write first and read it later, right? It's another pattern to read before write. I don't
In
understand.
Cassandra or in the database?
Yeah, it's not clear yet. So reads are more expensive. Really? In my mind, write is more expensive.
I think
Maybe it's
reads
in Cassandra.
because
Maybe it's in
write
Cassandra.
you can do only one action. I don't know if it's the word, but
Mhm.
write you can do only one action. It's okay to write, but read sometimes you need to read. I don't know, the whole database or the whole table, the whole thing.
I see. So write, you say you can put the information right there when you want, and
Yes,
the
one.
read like you need to search.
Yes.
Okay,
So
makes
I
sense.
think because their reads are more expensive.
Yeah, makes sense. So antipattern is like read before write, and Cassandra, and therefore everything that Cassandra does, it's essentially an upsert. Upsert, it's insert or update.
Yes.
If you try to insert and that's already exist, you're gonna update. So basically, they need to do read first, right? Because you try to insert, you need to check if that's already exists, reading the data. If that exists, they're gonna write. I think so. Okay, so even if you provide only certain column, so let's go back. It's an partner to read before write. Reads is more expensive in Cassandra, and therefore everything that Cassandra does, it's essentially an upsert. Even if you provide only certain columns, you can also write to any node, and it will resolve conflicts automatically using the last write wins. And
Mhm.
semantics using less routine semantics on a per column basis. So how did this bite us? So okay, let's because they have a problem with the author ID, right? If you go see here, they have author ID in the messages, and that's new.
Mhm.
They don't know why because why they that new. And that's about consistency, right? So consistency because we have a multiple nodes, so Cassandra, because we have a multiple nodes here. Consistency means across all the database, they need to be synchronized, right? Or something like that. And for some reason, they have a problem with the author ID because they said that Cassandra, it's not strong consistency. It's more AP database. I think the good example of consistency could be Postgres. Because normally NoSQL database like MongoDB, it's not strong consistency.
Yes.
Okay, so I'm gonna translate that for explain the Leo.
I didn't know that
Yeah,
exists.
in Brave you can have use that one. They can explain. So the
Mm.
SERP is this content database called Cassandra. What it is? Cassandra is a type of database designed to prioritize availability, or mean accessible, over consistency. Make sure that it's always accurate. This means that Cassandra might not always have the most up-to-date information, but it will always be available. It means gonna be not gonna be blocked. So some databases, when they don't have the information, the availability is low. They're gonna block you to give the information until they have the information.
Okay.
So reading writes. Imagine you're reading a book and someone else is writing in the same time. In the traditional database, you would want to make sure you are reading the most recent version of the book before writing it. It's called read before write. However, in Cassandra, this is considered an ant-pattern, which means it's not the best approach. Instead, Cassandra treats every write it's an upsert, which means it will either update existing data or add new data, even if you only provide some of information. So how Cassandra handles conflicts? When multiple nodes computers are writing to the database at the same time, Cassandra uses a conflict resolution mechanism called last write wins. It means that if multiple nodes try to write the same data, the last node to write will have the changes applied. So they're gonna override. Why this might cause issues? The sharp mentioned that approach bite us, cause problems. This could be due to various reasons, which the data inconsistencies or conflict that arise from the last write wins mechanism. Yeah, I can imagine now, like you have a node writing because they receive the information from the user, and the first writes have the author ID, but for some reason the last one don't have, so they're gonna put new there. I think. Oh, they show the image here. Edit the race conditions. One update, stun update, hello update. The second user, no. Yeah, because the last user can like delete the information if they're gonna always wins.
I see.
Yeah.
So how they solve this?
Yeah.
That's the question.
So in this scenario that the user edits a message at the same time another user delete the message, we end up with a row that was missing all the data except that guy deleted.
I see.
And that one I'm gonna delete, right?
Since all Cassandra writes.
Yeah. All missing data except the primary key and the text, since all Cassandra writes or upserts. There are two possible solutions for handling this problem. First, write the whole message back when editing the message. Yeah. So if you try editing only one column, but the other guy deleted everything, you're gonna have like just the one information and the other stuff new. So to not let that happen, they suggest every time you're gonna edit, you're gonna do all the information again. All information again. That's like bad, right? Like because you need to have in the first place all the information.
I didn't understand yet.
So you have a table, right?
Yes.
And let me see where I can show that without be here. Yeah, let's continue to read. Maybe they can explain better than me.
Yes. Okay.
And the second one is figure out that message is figure out that the message is corrupt and delete it from database. Figure out that the message is corrupt. So the first one is send again.
Two possible solutions. Write the raw message back and when edit the message. Okay, these had the possibility of resurrecting messages that were deleted and add more chance for conflict for concurrent writes to other columns. Adding more chance for conflict for concurrent writes to other columns.
Yeah, they said the solution, but also just said the problem. Like
yes.
You can have the raw message back, but possibility extraction messages that were deleted, and add more chance to conflict for concurrent writes to other columns. And second, figure out that message is corrupt and delete it from database. We went with the second option, which we did by choosing a column that was required, in that case author ID, and deleting the message if it was null. So basically, if they see author ID null, it means in some place the last write wins was to delete. But because happened another update, after they delete, they're gonna say the delete wins over everything.
Okay.
Yeah, basically, I think they did that.
Okay. Okay.
Yeah. While solving this problem, we noticed we were being very inefficient that with our writes. Since Cassandra is eventually consistent, it cannot just delete data immediately. It has to replicate deletes to other nodes and do it even if other nodes are temporarily unavailable. Cassandra does this by treating deletes as a form of write called tombstone. Yeah, I heard that in the past.
Tombstone.
Yeah. I think also tombstone you can see in the Tomb Raider film game.
No, I don't know. Tomb Raider. Tomb Raider.
Yeah. They have something called in
It's
the
from Lara Croft.
yeah. So
Ah,
tombstone in data store is a deleted record in a replica. So we have the replica here. Like that's gonna be the master. That's gonna be the replicas, and that deleted we're gonna call tombstone. The tombstone is necessary as distributed data stores use eventual consistency, where only a subset of nodes where the data is stored must respond before an operation is considered to be successful. Removal of tombstones, consequences. Okay, we could go more into that, but let's keep going here.
So that's so good because when we are reading, I think we read only two paragraphs, and we see a lot of things we don't know, a lot of terms we don't know, a lot of new things to learn. That's so good.
Yeah, we can learn a lot from that article, and that's just this first article.
Yes.
The second should be more recent. We're gonna have more and more stuff to learn too.
Yes.
So on reads, it just keeps over. So on read, it just skip over tombstones it come across. So let's let Lau explain that one too.
Tombstones leave. Well, tombstones live for considerable amount of time, think they and are permanently deleted during compaction.
Jefferson Luis Monsters. Hey Jefferson, welcome.
Jefferson House.
Let's practice the English.
We are doing live in English.
Yeah. So if you want to interact with us in English, it's gonna good practice. So so here it's discussing database system called Cassandra. Cassandra design to store and manage large amounts. When data is deleted in Cassandra, it does not immediately remove the data from all nodes. Instead, it marks the data as tombstones to keep track of what should be deleted later. By the way, tombstone, I think it's something about RIP.
Rick?
Yeah.
Rick?
Something. Yeah. Rest in peace.
Okay.
How? Túmulo?
RIP. Tombstone.
I think something about lapide, exactly.
Yeah. Tombstone.
Yeah, that's why
Makes sense.
That's why it's already also has in the Tomb Raider.
Okay. Makes sense.
So yeah, so they have like the tombstone, the lapide, say
Yeah.
the data is that, but don't remove that yet because I need to inform all the others nodes that the data gonna be deleted. I think they only clean the tombstone after all the other nodes confirm that they have removed it. You know?
Mm-hmm. Yes, I understand.
Yeah, makes sense, right?
Yes.
So why Cassandra does that? So eventually consistency, Cassandra is designed to prioritize high availability and perform over immediate consistency. It means that even if some nodes are temporarily unavailable, Cassandra can still function and provide data to users. Tombstones, when the data is deleted, create a tombstone that marks the data is deleted. This tombstone is treated as special type of write operations that need to be replicated to all nodes. The compaction. Over time, Cassandra's compacts
Yeah.
data to remove unnecessary tombstones and free up space. Process occurs when the tombstone creation time has passed 10 days by default. Nice. Yeah, the summary from Leo is better than the article.
Yes, from the article.
It's so clear saying mark the data as tombstone to keep track of what should be deleted later.
Yes. But I think the article has the goal to be more compact.
Yeah, makes sense. I agree. Jefferson said in the chat, I'm listening and learning with you guys. Nice.
Yes.
Also, Jefferson, if you know something we don't know, you can share with us too.
Yes.
Okay.
Jefferson is a good dev. He
Yeah.
worked with me in house.
Oh, yeah?
Yes.
Nice. I think I remember him from LinkedIn.
Yes,
They have a
he was.
mustache. They have a mustache.
Yes, he was working Itaú. Now he working with us in House Tree.
Nice.
Yes, he's a good blockchain developer and developer as well. You can see the he LinkedIn on the no. If you put Jefferson Luiz on LinkedIn, you can
Yeah,
see him.
I have him in the LinkedIn. I think in the LinkedIn they have a mustache and a hat.
I don't know. Let me see.
Yeah, we're gonna check here. Jefferson said, I remember Felipe LinkedIn posts. Great post to LinkedIn. Thank you. Jefferson.
Yes, he has a mustache.
Yeah. And the hat,
He-
right?
no, if without a hat, but he has a big hair.
Oh no, they have a V for Vendetta, right? You know the film?
Yes, I know.
V or
Vendetta. From Vendetta.
I don't remember the name. How the name of the film?
I don't know. I never saw the move, but I know what are you talking about.
Yeah, Vendetta. V for
Vendetta
Vendetta.
from Vendetta.
Yes, exactly. I had that same mustache in the past. Also,
That's cool.
very cool. You need to watch that movie.
It's a good one.
No, it's an awesome one.
That's so
Awesome.
cool.
Like it's a must watch movie.
The last one I was watching was Blade Runner 2049.
Very
That's so good, so good.
yeah. Awesome, very nice one. Okay, so let's keep in here. Compaction. So Tombstone also have a role to compaction data. Nice. So think of Tombstone like a to-delete list. Cassandra keeps over the Tombstone. Okay, it's Leo, it's very nice to explain stuff. So delete a column. That's why they said about the 10 days here. So in the read, it skips over timestamp is come across, timestamp leave for configurable amount of time, the 10 days by default, and or permanently delete during the compaction when the time expires. So deleting so can be a case where a database is off.
For 10 days.
Yeah, the node's off by 10 days, and the data can be resurrected, right? Resurrect. If the the node is off by 10 days and then go back because they don't have tombstones anymore, they can have the information again. I don't know if that's the case from the Apple. Apple have a problem in the past. Some data was deleted, but after some months, the data get back. I don't know if that was the case.
The Apple use Cassandra as a database?
I think so. Parts of the cloud service they have, I think they use Cassandra. I think so, though I'm not sure. But the concept Tombstone, it's not only from Cassandra, right? Other databases also have the same concept.
Apple uses Apache Cassandra, a NoSQL database management systems for various internal applications and service.
You check it?
Yes, these include large-scale deployment to services such as iCloud and Cloud.
Yeah, exactly, iCloud. So people on iCloud deleted some messages, photos, and after some time, the photos came back. And then it was a scandal because people said the Apple don't give a shit for your privacy, and I think they defend by self saying no, it's a tombstone problem, something. I think it was something like that.
Interesting.
Yeah. So delete a column and write new to a column, or the exact same thing. Yeah, makes sense. They both generate a tombstone. Since all writes in Cassandra are upserts, that means you are generating a tombstone even when writing new for the first time. In practice, our entire message scheme. So how we create let me see something here. How we create tombstone in Cassandra. We define rules for columns as new. I'm curious.
It's just a marker that says this value row was deleted. It's not about schema rules. It's about how you should delete it.
Okay.
Yes, I know that. Okay.
Yeah, so if you insert a column with new or omit a column and update when the split is set in new, Cassandra writes a tombstone. So they write a tombstone by column? What the hell?
So you don't configure a tombstone in schema, they generate at the right time to mark something as deleted.
Right. So here, for example, insert user ID new. So the tombstone here gonna be for name only. But they're gonna remove all the line. So let me see.
Only because they have a new.
If the users has more columns, they gonna remove all the line because of name new. Don't make any sense.
Yes.
No, set the name new, only tombstone is that column.
What the? No, I think.
Really?
Not the whole row. For name but keeps email. The only way to tombstone.
So they said the delete also works in different levels. For rows that we are used to do, by column or by partition. Yeah, that's advanced stuff. Cool stuff.
I can't see that in my mind yet.
I think so. You can imagine saving that database.
Okay.
Each column, it's a new table. You can see that?
Yes, I can see.
So if a lot of name is new, you can mark that as deleted, because when you're gonna search, in that table you don't want bring new stuff. I think that's the idea, but I don't think that we're gonna remove the whole row until everything be new. Let me check. So what's happened on the name new tombstone? Let's remove it. Marker. What's happening after write? The old value is hiding. Reads won't return name.
Okay.
Other columns in the row. Fact that until compaction or garbage collection grace. Sit there, make that name was deleted. Must remain for list. Grace seconds, default 10 days. So replicas agree during the repair or anti-author. After compaction, purge the tombstone and any other version of that column. At that point, name is just gone. The row itself continues to exist if it still has other live columns. I see.
Okay.
Yeah. So they are saying about the low level, how the database works. Makes sense,
Mhm.
right?
Oh, we should do a database from scratch.
Oh, that's a good idea.
Yes, but we can choose I don't know, C++.
No, please, no. Rust, please.
No, I want
Rust.
to learn C.
No, I don't. I don't. I am. See, it's so difficult. Rust is so simple. Yeah.
Database from scratch. Oh, you will have a book for that.
Yeah, probably they have a lot.
Build your own database. I think this book is on C. I have 100%.
Here, that should be something we can follow. Build a
Ah,
database from scratch in Rust. That should be beautiful to do. So we're gonna build a REPL, tokenizer, a parser, code generator, a B-tree, and
B plus
pager.
OS interface.
Yeah, nice. Do you know I built in the best database.
Yes, I come with idea because you say so.
Yeah, but was not all that parts, only the SQL parser, and I have like a file, and then I need to create a way to save all the data, the tables and columns in the data file like a text file, notepad text file. So it was more simple because it was to read in the GVM in mobile, like before Android exists. Was very cool stuff. Yeah, maybe we can like read the articles because we're gonna understand a lot of stuff deep just reading that one. I can see already a lot of stuff here.
Yes, we can save to read later.
Yeah, you can see a lot of good stuff. Virtual machine. Nice conclusion. Wait, what's the rest?
It's the piece one, part one.
Yeah, but they don't have part 2 here. Link
Conclusion.
or never finish.
Part one.
Come on, Paolo. Paolo Reccia. Don't have part 2.
Yeah. We will make the part 2.
Yeah, probably. Okay, so that's a good one. Row is removed completely only if all columns are deleted or TTL expire. So TTL, it's I think it's time live.
You can see in the beginning, I think.
They said something here, right? Time to leave.
Yeah, time to leave.
Yeah, that concept we saw across a lot of stuff like domains. When you create a domain, you can define TTL.
I think we saw something about this yesterday when we have cache, no cache.
Yes, exactly. In Redis or cache stuff, yeah, TTL. You are correct. Okay, so let's see where we stopped. About generate a tombstone. Since all writes in Cassandra are upserts, that means you generate a tombstone even with the writing new for the first time. In practice, our entire message schema contains 16 columns, but the average message only has 4 value sets. We are writing 12 tombstones in Cassandra most of the time for no reason. Yeah, makes sense. The solution for this was simple. Only write no null values to Cassandra. Then they're gonna have the problem they have before, no?
Which one? This?
Yeah.
Less right wing?
Yeah, let's see.
Let's see performance.
Performance. Cassandra is known to have a faster writes than reads. And we observe exactly that. Writes were sub-millisecond and reads were under 5 milliseconds. Oh, 5 milliseconds is long time. Like bigger.
Yes.
It's like 5 milliseconds. In microseconds is how much? 5,000?
5,000?
Maybe. We observed this. So that's fast. I was compared with the pinging stuff, like 80 milliseconds. We observed this.
Regardless.
Yeah, regardless of what data was being accessed, and the performance stayed consistent during a week of testing. Nothing was surprisingly what Isaque we expected. So read latency, write latencies. So around 2, and here around 0 something 6 top. So the write is very fast. So latency via Datadog. You know Datadog?
No.
Good service for data logs and stuff.
Datadog.
It's a big company. Modern monitoring secret. It's a company for data, basically. You see Samsung, Nasdaq, and all big companies use. Yeah, that guys know a lot about databases, like a lot. You know how the company is big, when you see the product, you have a list like that. Yeah, you have like certification, you have like
products.
You have like privacy center. It's not like a terms, just a center. Jefferson said, we use Datadog and Itaú. Yeah, exactly. Datadog is huge. Huge.
Transparency.
Yeah, they have a privacy data center just for privacy data, because sensible stuff. By Hagen. Imagining the DevOps. Jefferson said, we changed from Prometheus, Jaeger, to Grafana. Yeah. So Prometheus and Grafana. Prometheus. Or good ones for small products. Or if you have like a DevOps. But for something big, Datadog, it's very so Grafana.
Grafana we use today in house.
Yeah, it's very good, Grafana. I use in some projects. Very cool with Prometheus. They have a cloud too with the 10K. Yeah, I don't know the prices, but I think like Itaú, something big, Datadog should be better.
Pricing.
Centralized monitoring.
Machine learning.
I think compared to Grafana should be that one, right?
Out of the box.
Yeah, you can use machine learning in Grafana with some plugins there. Yeah, maybe that one. but that's for per host.
Mm-hmm.
I think you need more, depending on the system. Yeah, okay, let's go back. Uh, in line with fast, consistent, and read performance, here's an example of jump to message from 1 year ago in the channel with millions of messages. So they go here, open the in messages, and click and go.
Crazy.
Fast. Jumping back 1 year, and
1 full year.
they said the chunk in 10 days, right? So basically
10 days.
the database have like
Mhm.
36 chunks for 1 year for that channel. That's why it's so fast. The big surprise. Everything was smoothly. So we roll it out as our primary database and phase out MongoDB within a week. So phase out is expression to power up.
Phase it out. Why phase it out and not power it off?
Yeah, it's expression in English. I don't know the origin,
I think
but
it's like passou para trás, something like that.
that phase it's fase.
Phase out.
Yeah, so that
Deixamos para
a
trás.
fase
Yeah, it's
a fase
something more.
saiu, né? Yes.
Ah, retirar gradualmente algo como um produto, sistema. Ah, prática ou tecnologia, em vez de fazê-lo de forma imediata.
Yeah.
Interesting. We have a phrase only for that.
Yeah,
That's
and we have also another called sunsetting too. Sunset and sunset it's something about the sun.
phase out.
You can see here.
Sunset
Yeah.
is, yes.
So in sunsetting computer, sunset a server or service or software is planned to intentionally remove or discontinue it.
Mm,
So I think I heard first time in Web3 or even before, and
mhm.
they said we're gonna sunset the services, and then they have like 1 year to do that and announced for
Mm.
all the users do the migration or
Yes, I think sunset is because the sun,
yeah
the sol,
yeah
so it's something is low, so you have time to do the things and so on, but you know you're gonna happen.
yeah the night gonna
Yes,
be there.
yes, exactly.
So the phase out Mongo within a week. It continued to work flawless for about six months until that one day where Cassandra became unresponsive. Damn.
That's crazy.
Yeah.
Imagine this week in Discord.
We noticed Cassandra was running 10 seconds. Running 10 seconds stopped the word GC constantly, but we had no idea why. We started digging and found a Discord channel that was taking 20 seconds to load. The puzzle and dragons should be ready. I can see something funny happening already. I can smell. So puzzle and dragons, the guys have like 50k members. Imagining the Discord.
Yes.
Let me see the Discord. If we can find the Discord, should be massive. I think. Yeah, because here it's not too much. I cannot find. Okay, no problem. Public Discord servers was culprit. It's culprit?
I don't know what does that mean.
Culpado.
Culprit. I never heard
Yeah, I think it's
this one.
culprit. The name. Why it's not working? I think it's too much extension. Oh, because I never refreshed that page. And the thing gonna back here below. Yeah.
Yes.
Close that without.
Zoo de Gambiarra, the horse.
Man, that's so bad. Why they do that? Why don't they don't have a hide stuff? You know. Here, here.
Cool.
Okay. So now we can see. What?
Culprit.
Yeah,
Oh,
I
I
think it's
can.
culprit. I think it's
I
culprit.
can. I can't hear.
No, not me. No, me too. So yeah, I think it's culprit.
Culprit.
Since it was public, we joined it to take a look. To our surprise, the channel had only one message. Really?
Culprit.
Culprit, right?
Culprit. Yes.
Yes. So it was on that moment that became obvious they deleted millions of messages or API, leaving only one message in the channel. Ah, I see. So the Cassandra is starting running the GC like every 10 seconds. In that subreddit, in the Discord server, they discovered that the channel has only one message. So they delete millions of messages on our API, leaving only one message in the channel. If you have been paying attention, you might remember how Cassandra handled deletes using Tombstone, mentioned in eventual consistency. When the user loaded this channel, even though there is only one message, Cassandra has had to effectively scan millions of message tombstones, generate garbage faster than the GVM could collect. Wait, GVM?
Then the GVM.
Cassandra is writing Java?
I don't know.
Oh my goodness. Yeah, because Apache has had Tomcat, right? The Tomcat was for Java stuff. I can't believe it. It's Java. So that's why they changed for C++ stuff in Billions because because Java is
Documentation.
Java is not good for that.
Or in ChatGPT, you
Now
can ask.
I think I want to see the GitHub.
It's
Cassandra.
open source.
Yeah, open source database. No SQL.
Yes, they told because they want a
Here.
open source database.
Yeah, do you remember the requirements?
Yes. Java.
Java. They have Java, Python, Lex. Never heard of before. Documentation maybe. Or scripting. So Java. Think about that. Java. Oh my goodness. Let's IO. Input, output. Right into the disk. You have like disk error.
Mm.
Yeah. Would want to understand and study. I think if you go like Cassandra in Rust. Oh no, that's a driver. No, that's
Oh.
just drivers.
So we can do a Cassandra in Rust.
Yeah, I think Cassandra in Rust is gonna be awesome because they create a Scylla.
DP?
That one, Scylla. I don't know how to spell that. And that one is Cassandra in C++.
Ah, that's the one they chant in trillions
In
of messages,
trillions.
right?
Yeah.
Yes. C++, aí.
It's compatible with Cassandra in Dynamo. And if you go Rust, no. Okay, so let's go Perplexity. Cassandra writing in Rust. No. That's a client. That's a wrapper. That's a driver. No, don't exist. Exists some Cassandra type database writing in Zig or Rust. I remember a database called writing in Zig that was very, very fast for some company to try solve some problem. I don't remember the company now, but
There is no widely known database.
yeah, Styla written C. No, no, no. They have exist a famous database written in Zig. Do you know Zig?
I
Yeah,
have
Tiger,
heard
Tiger,
and
Tiger Beetle.
either.
That one. That's a fucking awesome database. The promise they have, like it's
Oh, the financial transactions database.
yeah, faster, faster, faster.
The
So
power
I don't know.
net.
I don't remember the client. But it was something like Visa, Mastercard, or something like that.
They
Financial.
use
Yeah, I don't remember if it is the same client, but they compare the use for Visa. Like they have like a lot of transactional stuff, and then they create the database writing in Zig. So the performance here,
Talking about that, which technology Pix use?
Pix.
Yes.
I don't know. I think something about Microsoft because the government uses a lot of Microsoft stuff. So maybe SQL servers.
We can hear about Pix in another life to see what technology they use, what
Yeah, if you
system design, or something about Dex.
yeah, the direct gonna be use the Hyperledger Besu blockchain. So let's see the clients. They should have the clients right here. Yeah, the primitive they like have IT accounts. It's like a blockchain stuff, linked events. They create a database to be very, very fast for financial transactions. The Primeaging, the fastest and safest database. I don't remember where the company was used. Maybe in the if you watch the video, you're gonna
See,
see.
blue sky.
Yeah, it's freezing. I don't know why the page is freezing.
I think it's because of the
Animation.
yes in blackout extension.
Maybe it's freezing. Yeah.
The whole PC.
Okay, that's working. At least.
Yes.
But here it's dead. Look at that.
Oh, 99. Why?
I think it's OBS. Crash reporter. Q. That's gonna finish. Oh, that's gonna finish the Google Meet.
Yes. But you can finish and I come back.
Let me see if that's. Oh, that's closed. Okay, nice. We are so we are so back. We are so back. So Escalite wrappers, being Ziggy. Yeah, okay. It's Tiger Beetle.
1 second, I will get my charger.
Okay. Close here. So let's close the tombstone. Cap theory. Keep AICT. Yeah, GVM. Solve this by doing the following.
I'm back.
Nice. I'm gonna go to battery real fast. You can continue reading the stuff.
Okay. So solve this by doing the following. And we lowered the lifespan of tombstones from 10 days down to 2 days because we run Cassandra repairs as an entropy process every night, or message cluster as an entropy process. Anti-entropy. What does that mean? We change your query code to track empty buckets and avoid them in the future for channel. This means that if a user calls this query again, then at worst Cassandra would be scanning only in the most recent bucket. We changed our query code to track empty buckets, okay, and avoid them in the future for a channel. This means that if a user calls this query again, then at the worst Cassandra would be scanning only the most recent bucket. Okay,
Okay, now explain me.
I didn't understand. That's the third time I'm trying to read this.
Yeah, sometimes I read something in English, but while I'm reading, I cannot understand. Then I need to stop,
Yeah,
translate to
and
understand,
talk
right?
about the.
Yeah.
But
So
what is the thing I am in doubt? It's about anti-entropy process. What does that mean? That's the first one. Anti-entropy.
okay, let's Leo help us.
Metals. Newer version. What is the future? Yes. We change our query to track empty boxes and avoid them in the future.
Where are you reading that?
In the second paragraph.
Ah, okay. We change our query code. Okay, so let me first read it here, then check the. We lowered the lifespan. Let's remember the problem. So that's what the problem. We solve this by doing the following. We lower the lifespan of timestamp from 10 to 2 days. Because we run Cassandra repairs
An anti-entropy process.
on an entropy process. So that's some tooling, I guess.
But what anti-entropy means?
Entropy is something complex. Now, I think entropy for database should be something specific. I don't know what it is. Every night in our message cluster. Let's see. So the problem is Cassandra database designed to hire and subnet. Okay. What solution? To solve the issue, Discord made 2 changes. Lowering the lifespan. They reduced the time it takes for the tombstone to be permanently deleted from 10 days to 2 days. It means that Cassandra will clean up tombstones faster, reduce the amount
of data
that needs to be scanned. But so the problem happens here in the puzzle was
because
the guys deleted it using the API. But because they use the API between 10 days, the tombstone was never removed. So that was slow, right? So why going to 2 days change that? That's the first question. How should they solve that? It means that Cassandra will clean up faster, reducing the amount of data it needs to scan. Okay, tracking empty buckets. They modified their query code to detect when the bucket collection related data it's empty. If a user tries to query an empty bucket, Cassandra will only need to scan the most recent bucket, reducing the amount of the data it needs to process. Okay, so that one don't solve the problem. That solve the problem. Because that one just, if the guy again use the API to delete millions of data, you're gonna have the same problem. That one resolve the problem because they're gonna ignore others' empty buckets. By the way, they should be done that in the first place. Why are you gonna keeping querying bucket that's not empty? Do you remember the bucket?
Yes.
Here they have a bucket.
We have all the messages.
Yeah, they create a buckets here.
Mm-hmm.
Channel if each 10 days. So the repairs. It's archived. Don't know if that still exists. At least to version 2.1. Performing an anti-entropy node repair on a reckless basis is important, especially in the environment that deletes data oh, Jesus Christ.
Frequently.
The repair command repairs one or more nodes in the cluster and provides option for restricting repairs to a set of nodes. Anti-entropy nodes repair performs the following task: ensure that all data on the replica is consistent, repairs inconsistencies on the node that been down. Why they call it anti-entropy? Anti-entropy.
Yes, I mean with the wording.
Let's see.
Anti-entropy. What is
anti-entropy node repair? Anti-entropy node repair is a process that ensure. Okay, let's understand why call that. Why call anti-entropy? Comes from the concept of entropy, which is a measure of disorder or randomness in the system. In physics, entropy increases over time as energy becomes less organized and more dispersed. In the context, by the way, in the cryptography, you use entropy to create a hard, like private key. Taking a lot of data come from chaos, like taking most data that don't have a order, so that's why disorder. So you cannot reproduce the same data to recreate the same private key. Okay. So for example, we have places that use the mouse location, where the mouse it is, like X and Y. What's the time? What's the how many tabs it's open? With the titles of the tabs and do a hash. A lot of kind of data should be impossible to people recreate the private keys.
Okay.
So in the context of data storage and replication, entropy refers to inconsistencies or errors that can occur when data is copied and stored across multiple locations. As data is updated or deleted, these inconsistencies can lead to kind of information entropy, a degradation of the accuracy consistency of the data. Okay, I now understand. The fight entropy, making things in orders or consistency. So that solved the problem basically. They just put less to make clear more fast. Don't accumulate more data. Too much data. Okay. So the future, We are currently running 12 node cluster with a replica factor of 3, and we will just continue to add new Cassandra nodes as needed. We believe this will continue to work for a long time, but as Discord continues to grow, there is a distant future where we are storing billions of messages per day. Netflix and Apple run clusters of hundreds of nodes, so we know we can punt. I don't know that word.
Punt. Apostar.
Like bet.
Punt too much about his for a while.
Punt thinking too much about this for a while. Whatever, we like to have some ideas in our pockets for the future. So in near terms, upgrade our message cluster from Cassandra 2 to Cassandra 3. Cassandra 3 has a new storage format that can reduce storage size by more than 50%. Awesome. That's probably the current one. Yeah, May 2025. Putting some structure in the storage engine. So they did a refactor for the storage engine. You can see here in the Jira issues. So the type it's improvement, normal, it's 3.0 alpha, the date with the dates created in Jesus Christ. Okay. Yeah, they had a lot of blocks, a lot of subtasks. Yeah, that's a big stuff, right? So it's not something easy to do. Yeah, change the engine should be. Imagine how much bugs you can introduce doing something like that. Huge. Okay. So the old way, they said they're using sorted map. Map, it's like a hash map in Java. Key value. And the new way, the old way, it's a map. It's a map with a shorted map inside. So that's a hash map without order. That's a hash map with order. Has been replaced by something like more bytes, and now they have a clustering in row. So here was a cell and bytes, like could be a blob, and here it's now clustering. And clustering Java file, what is this? What is this? They have a V from prefix in memory serializer. I remember some Java from the past.
And didn't see Java.
Java is very, very easy to learn. Okay, they have a complex type, and they use the serializer to write the object to files and do the opposite too. But basically, I can see here they accept the V, like a bytes, and they add some functions like start bound and end bound. I think that start bound and end bound is to make clustering more easy across nodes. I'm guessing. Okay. And then they have a lot of other stuff. They changed the role Java class too. Let's see that one. That should be cool. Oh, my camera gonna die. No. I'm gonna lost the camera. Sad story. Let me try.
Run. Java 1. So what do you guys think about the life in the
5, 4, 3, 2, 1, 0. No. Oh shit. That was so close. That was so close. For 2 seconds. I could not save my camera. Be dead. You're here? You're there?
Yes, I'm here.
Okay, let's finish that stuff. think that's the signing.
To end life. To end.
They
the
have a
art.
cell reducer. That's so funny.
What is that do?
I don't know. It's an iterator for to do force. They have like a cell inside. They have active deletion. I think that's the could be the tombstone here.
Okay.
Set active deletions. Yeah, so complex. Complex stuff. They have a complex builders here.
Literally complex.
Yeah. They have a column data reducer. Nice. That's just a raw file. Imagining all the database stuff. Imagining. We have an abstract row for extending. Buffer cell. Cell extend from row? No, from column data. The column
So
data.
we will do all of that to do a database
Yes.
or not?
Yeah, exactly. So they have the column data. They have an interface called memory memory, just to see how much in the memory it's used. Reconciler. Yeah, that's complex stuff. I think it's, if you want to contribute, you're gonna take 6 months or even 1 year to understand all the code base.
I think it's good, but I will learn a lot.
Yeah.
We will do in Rust.
Yeah, we can use it. You can use AI to do that, right? AI can just. Jeff Source said the camera dies for me. Yeah, exactly. I'm gonna restart the camera. But I think the camera from
The notebook.
you is working.
Yes, my camera is working, only
Your face.
you're not.
So the near term it's upgrade from 2 to 3. I think they already did that. A near version of Cassandra were better and handling more data on a single node. We are currently store nearly 1 terabyte of compressed data on each node. We believe we can safely reduce the number of nodes in the cluster by pumping this to 2 terabytes. 2 terabytes. Man, imagine in Discord. Look at that. Look at my Discord. I have so much servers here. And it's not even close in how many servers exist in Discord. And
wow, that's
imagine how
another
much
server.
messages it's running here.
And servers and so on.
And that I have another one, a lot of folders. They have another folders here, a lot of folders. And they said they only have 12. They're using only 12 terabytes. And each one in 1 terabyte, so it's only 12. It's like,
Well,
it's insane how much little space you need to do. Billions.
But it's this time, right? Yes, billions of messages.
Yeah. Long term. So exploring, yeah, for trillions, they're gonna do something different. So long term, it's exploring using Scylla. I think it's called, it's Scylla.
Scylla. Let me see.
I think it's a Greek.
Scylla.
I think it's a Greek name.
Greek.
I think it's Greek name.
Scylla. Scylla.
I think it's Scylla. Let's see. But
in English, it's Scylla, but I don't know if it's Greek.
Look at that.
In Greek.
Greek mythology. So I'm not so bad in. So I think the pronounce is different in Greek. That's why.
Scylla too.
You changed to Greek?
Yes, Scylla.
Scylla.
Yes, sir. In Greek mythology, Scylla, Scylla. Yeah, pronounce Scylla.
Skyla.
You can see direita, right? Yes.
Do you
Is a
know?
legend?
Do you know where
Yeah.
I learned about Skyla?
No.
In the game.
Where? What game?
I'm trying to remember the game. I think I was good of War
God of War. The goat.
for Greek mythology. I think
Nice.
so. I don't
Oh, you
remember.
can put Skyla. God of War, Skyla.
Yeah, Skyla.
God of War.
I think it was good of War. I don't remember. Yes. You see
God
here.
of War with
Yeah,
fun.
but it was not that personage. I think it was another.
Watch of
Yeah, that's
Skyla.
one. Skyla. Skyla.
Cool.
Yeah.
Mm.
Gaming. Yeah, Ghost. I think it was that one. Ghost of Sparta 2010. Damn, 50 years ago.
16, yes.
So
50. We are in 2025 yet.
Cassandra. So Cassandra Compatible. So Skyla is Cassandra Compatible database writing C++. Just let me open my camera. You can read for us. Then I configure my camera.
Yes. Exploring using Scala as a Cassandra compatible database writing in C++ during normal operations or Cassandra nodes are actually not using too much CPU. However, at non-peak hours when we run repairs as an anti-entropy process, they become very CPU bound and the duration increases with the amount of data writing inside the last repair. Scala advertises significantly lower repair times. Advertises build a system to archive unusual channels to flat files on Google Cloud Storage and load them back on demand. We want to avoid doing this one and don't think we will have to do it.
The
Build a
camera. The
system.
camera back.
Let me see. In life. Yes.
Nice. So what do you understand here?
Nothing. Exploring using Scala Cassandra compatible database writing C++. Okay, Cassandra nodes are actually not using too much CPU. During normal operation, Cassandra nodes are actually not using too much CPU. Okay. However, at non-peak hours, when we run repairs, they become fairly CPU bound. What is mean CPU bound? And the duration increase with the amount of data rise since the last repair. CPU bound, I think bound.
So bound. It's like a border.
Increase border.
It's like,
Okay.
so you saw my CPU bound to the 100%.
Mm-hmm.
Like
Okay.
almost in the limits.
Understand.
We have also bounce that's close to the, yeah, you can see limits,
Mm-hmm.
but we can also use like bounce if that's like go up and then go down.
And the duration increase with the amount of data writes written since the last repair. Lower scale advertising lower repair times. Advertises.
Yeah, advertises is like saying, like warning.
Okay. Build a system to archive unusual changes to flat files on Google Cloud Storage and load them back on demand. We want to avoid build long term. Okay, long term. Build a system to archive unusual channels of flat files on Google Cloud Storage and load them back on demand. Okay. We want to avoid doing this one and don't want to think we will have to do it. Why? Why they don't want to do that?
So build a system to archive unused channels to flat files on Google Cloud Storage and load them back on demand. We want to avoid
Mhm.
doing this one and don't think we're gonna We will have to do that.
Have to
Yeah,
do
like archive. Archive is like take the data,
Well,
like compress and save that in Google Cloud Storage, and they load back. Imagining how the system you're gonna put a lot of load in the Google Cloud Storage
mhm.
and have a different system just to be able to remove the load from the terabytes from the Cassandra. So that's something they thought that can be useful in the future in the long term, but they don't want to do that. But if they need it, they're gonna do that.
Okay.
Conclusion: it has now been just over 1 year since we made the switch, and despite the big surprise, it has been smooth sailing. Sailing, it's about navigation.
Navegação.
We went from over 100 million total messages to more than uh, 100,
Well,
100,
I'm explaining
120 million messages a day, and with the performance and stability staying consistent.
yes.
Due to success for this project, we have seen moving to the REST or live production data to Cassandra, and that has been a success. In the follow-up to this post, we explored how we make billions of messages searchable. We don't have dedicated DevOps engineers yet. Really?
Only 4 backends engineer.
Damn.
Crazy.
Yeah, that's crazy.
So have a system we don't have to worry about has been great. We are hiring. So come join us if this type of stuff.
Okay, let's see the jobs.
I think now they have, but at the time they don't have.
Yeah, let's see the current jobs. Don't just imagine the future of gaming. Build it with
Build-
us. So they looking for senior director, mobile gaming. Let's see something related to the data.
Advertising. Business, core team. Yeah, core tech engineer.
Yeah, they have a
Storage
storage
platform.
platform. They have manager client platforms.
Privacy engineer.
Oh, that could be fun.
Yes.
Desktop platform. Audio video clients, cool. Audio video infrastructure, cool stuff.
Most of the guys are from DevOps.
What do you mean?
Infrastructure.
Yeah.
Desktop platform.
Yeah, the desktop platform is gonna be front end too, because they use like React with the Electron.
Mm-hmm.
Data platform, data platform.
No, data science and data engineer.
Yeah.
Data science, senior data science,
Analytics.
senior data science,
It's
analytics.
then legal, IT, legal, machine learning.
Dev software engineer, machine learning. How much they pay?
I don't think they have the price here, but we can check. Products, general, product design, core product, senior integration engineer,
Oh,
player, product
product
engineer, ads growth, ads core, subscriptions, apps, now UI interaction full stack. Oh, that can be remote in the US. Cool stuff. Because living in San Francisco Bay Area, it's
expensive.
yeah, something I don't think you're gonna like. Yeah.
Why not?
Because I think I like rural stuff. A lot of nature.
Okay, yes. It's like a selva de pedra. It's São Paulo from New York.
Yeah,
from
San Francisco has a lot of beautiful stuff. Like it's a Bay Area, so Francisco. Oh Jesus! No, not that one. Francisco.
PGE, Rio 3. Morar no Rio? Nah.
Yeah, I think it's gonna be that area.
São Francisco?
Yeah.
Twin Peaks?
So
Golden Gate
yeah,
Park.
if I can choose, I could choose another place easily. For example, if I need to be here in California, I think I'm gonna go to the north. We have a little city here. I don't remember the name. Good one to live. I think it's Rosewood. I think it's Rosewood. A lot of green. I choose easily something like that to live. Beautiful town. Cool. But yeah. So here they have the Discord used by 200 million people every month.
Play video games.
Yeah, billions of hours. So raise 8 years of machine learning.
Inclusive PhD or master degree in computer science, machine learning, artificial, or mathematics.
Strong,
Deeper expertise in mainstream hexes. What is the mean hexes?
Here? I don't know.
Model architecture, 2 towers, transformers based model, task learning, okay. Wide and deep, strong efficiency.
Ooh, nice one. Plus equity.
So,
plus equity.
To be a senior in Discord. To be a senior in Discord.
Yeah.
6 degree, 300.
Good one, that one.
300,000.
The position US based and can be remote, but if you live in the Bay Area, you are welcome to work for beautiful San Francisco offices. Sparking Flink. Yeah. That's a good company to work, I think.
Discord?
Yeah.
You think so?
Yeah, for sure. For sure it is. I want to check the more normal, like that one, for example.
I think the good one, oh no. The good one to see about machine learning is Tesla.
Yeah.
I think we can work
so
with
that one is for desktop, Mac OS, Windows, Drive, Troublestop. 5 years. Working on large and cross-platform desktop applications. Electron. Expert in Mac OS and Windows application. Rust, nice. So if I'm seeing Rust here, it means they are preparing to get out Electron someday. To go to Tauri, maybe the same I use in the Cap2, for example. Because Electron is so slow in B, and maybe in the future, if that keeping growing too much, they want to migrate, and if they writing some libs or something in Rust, they can easily change.
I understand.
Yeah. Solvent bonus experience in Objective-C. ++ that's from iOS. Now they're using Swift and TypeScript in Python. Because why? For the mobile application?
I think so.
But that's for desktop. No. Forget I said. The Objective-C also was used to build macOS applications. Now they use Swift, but you can keep using Objective-C. Okay, comfortable reading and write coding. So the Electron, Objective-C, Rust, and TypeScript. How Discord seamlessly upgraded millions of users to 64-bit architecture. That should be awesome to read too. Less, you see, like 100,000 less.
Yes.
compared to machine
Machine
learning.
learning position.
Yeah, but also machine learning position was requiring PhD, and people need to invest a lot of time and money to have all this stuff. Nice one. And the privacy to last one, I think should be less. The privacy gonna be less.
Less?
Yeah.
You think so?
Yeah, the same.
Oh,
Oh.
senior privacy. That's a good one.
Candidate
Candidates
residing willing to relocate to San Francisco Bay Area. Yeah.
Santa Clara, São Francisco, Solano.
Yeah, like people need to go to there.
Alameda, ATL.
Python for user privacy, 3 years of private security engineer, 3 years of Python where to go, blah, 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 and blah, blah, blah. Nice. Very nice. And for that, you need to understand how system design works for sure.
100%.
We don't have dedicated DevOps, so come join us. So we finished that one, and we're gonna continue that. I think it's Tuesday.
Yes.
Tuesday something.
Yes. Tuesday.
We're gonna read the Trillion. That's more recent, 2 years ago. They're gonna explain how they get out Cassandra to go to Skyla. And they're gonna explain some cool stuff here for us.
Mm-hmm.
Python API, some services, very big migration. Imagining that super disk storage topology.
Oof, that's a good one to see.
Yeah.
This kind of migration and how they do that.
7 months later, 4 terabytes. Damn, 177 nodes.
Each SkyDB node has 90 terabytes disk of space.
Yeah. Yeah. That's gonna be awesome. Okay, let's finish then. We learn a lot about Cassandra and why that's not working. Okay. We'll learn about a Cassandra cap theorem and some strategies to do migrations. Yes, they're for sharding. Very cool.
That's it for today, guys.
Yeah, let me change the face here. So thank you for the guys. Jefferson Luis here and other is there. Learn a lot. Nice. And we're gonna see tomorrow. No, tomorrow no. It's Thursday, right?
Tuesday. Yes.
Thursday. Probably more early. Jefferson said thanks.
Good night for you guys, for you
Good
too, my
night.
man.
Night.
See you tomorrow.
And see ya.